Let's discuss the 2020 essay paper. Question number 5. Draw a free body diagram of the block for the above situation. The situation is uniform block of mass M in horizontally rough plane, then a horizontal force P which is gradually increased from 0 is applied to block legs friction force to F. Horizontal force and the friction force on the uniform block. This is the uniform block. This is the mass and this is the reaction force and the P force. If the free force in this direction, the friction force is applied in the opposite direction of the P. This is the friction. This is the horizontal force on the block. Sketch a graph of friction and the horizontal force. Initial position until the block moves with acceleration. Mark the limiting friction and dynamic friction force. When we increase the P, also increase the friction force until it reaches the maximum. Then it reaches the maximum, then the friction force is going to the dynamic friction. This is the limiting friction. When P is increasing, the friction force is also increasing. Then going to that point is the maximum force of friction force. Then it's going to limiting friction, dynamic friction. When dynamic friction starts, it goes down and then it's constant. Dynamic friction is a constant. Yeah. That is the limiting friction. That is the dynamic friction. In that point, the block start moving. Write down the expression for the coefficient of limiting and the dynamic friction. Limiting friction over M G equals limiting friction coefficient and dynamic friction over Mg equals dynamic coefficient, friction coefficient. a front wheel drive car. Then they ask the situation when the car accelerates. So front wheel drive, front wheel drive and rear wheel drive. In this question, we have a front wheel drive car. In the front wheel drive car, the front wheel use the force to move. The engine is directly connected to the front wheel. Then front wheel start rotating, the car is moving. Then also due to the friction force, rear wheel also rotate. In the front wheel drive car, the front wheel's friction force should apply in the moving direction. The rear wheel friction force apply in the opposite direction to the moving direction. First question, the situation when the car accelerates on the horizontal state of the road as shown in the graph. Copy the wheels A and B. A and B. This is A. This is B. Friction force. Also compare the magnitude. When car start moving, the magnitude of the friction forces are not equal. The front wheel drive force, friction force is higher than FA, is higher than FB. That's why the car is moving. The force applied to the front wheel, that's why it's a front wheel drive car. The force is applied, then due to the road, the friction happen in the also the moving direction. Then the car start moving. Then when car is moving, this wheel also rotating due to the road touching. Then friction force applied to opposite direction. This rotates this direction. The force applied in the engine shown in the opposite direction. The mass of the car, including the driver, is 12,000 kilograms, which is equally distributed over the 4 wheels. Identify the correct coefficient friction acting in the situation. Calculate the maximum initial driving force of the car on the horizontal straight tar road. Friction force equals mu R. Mu is limiting friction. Mu L 0.8. Maximum initial driving force. Maximum initial driving force is given when the friction is in the limiting friction. Limiting friction coefficient is 0.8. R is 1200 kilograms into 10. We can calculate 0.8 12,000. They ask force. Maximum initial driving force. Maximum initial driving force only apply to front wheels. The all weight of the car on 4 wheels. Then we want to find the maximum force in the front wheels. Then maximum friction in the front wheels. The maximum friction in the front wheels, then we have to put the R only for the front wheels. Then the mass is will be divided by 2 and 0.4 8 4 0 0 8. That's the maximum force, maximum driving force. When the car is moving at the uniform velocity of 72 km per hour in the horizontal straight road, the total resistance against the motion is 520. Find the power of the car at that velocity. You know power equals force into velocity. Power equals force into velocity. Force is given 512. Velocity is given by kilometers per hour. We should convert meters per second. 72 for meters per second. 72 kilometers per hour. Per hour, 72 kilometers. Then per hour, how many meters? For the per hour, then 72,000 kilometers. Then per minute, per second, we should divide that with minutes and seconds. Six 36 into 20 104 watt. That's the answer. Then next, the car climbed the steep road with the angle of 12 degrees. The horizontal has same power in V. If the total resistance against the motion is 200, find the maximum velocity. Let's say question number is 3. This is 3. This is 3 and this is 4. This is the car. The car. Climbing at NG, then this direction NG sin theta is on this direction. Then we say the against the motion is 200 Newton force applied against the motion. Okay. And these two forces will be added. Find the maximum velocity. The power is the same as the previous. And P equals FV. Is force is mg sin theta plus 200. Mg sin theta. Mg is 12,000 mg. 12,000 sin theta into sin theta plus 200 into V. Into 12,000 into sin theta, they given 0.2 plus 200 into V. V is 10,400. 2400 plus 200 into V. Then V equals 10,400 divided by 2,600. Then 104 over 26. 146. 1, 3, 5, 2. 26, 36, 39, 49. Is maximum value to vehicle can only reach maximum value is 12. Minus 1. The answer. The next question. While the car was again moving from velocity 72 on the horizontal straight road, then the driver suddenly saw the obstacles from distance 35. When he quickly applied the brake, the four wheels overlocked and the tires started slipping. Then slipping, that means the dynamic friction. Slipping, that means dynamic friction. Without rolling, identify the correct coefficient friction. Coefficient friction is when the slipping means the dynamic friction. Until the slipping, only limiting friction. Then start slipping, limiting dynamic friction is applied. In this situation and by giving the appropriate reasoning and calculation. we have to give the reason for the friction. When wheels flipping, dynamic friction is applied. Mu V is given 0.5 from the above. On the B section they given mu D. Then they ask car state whether the car would hit the obstacle or not. When the car is moving in 72 kilometers per hour. Then the driver saw some obstacles in the road. Then driver applied brakes. Then car starts flipping. Car starts flipping. They ask then if the driver applied brake, what happened to the car? If the car is going to the obstacles, or car is stopped early in the obstacle. We can calculate that using the friction force, dynamic friction, mu d r. Then four tires start slipping. Then mu d is 0.5. Force, reaction force in the 4 tires also equals to the mg. Then 6000 Newton force applied by the 4 wheels in the opposite direction. Then car is slipping. Then the friction force applied to the opposite direction. Then car is slowing down. We have to find the time and the distance to stop the car. Then we want to calculate the acceleration of the car. The acceleration F equals A. F is 600,000. M is 1200. A equals 60 over 12 is 5 ms minus 2. That's the acceleration. We should find the distance by v square equals v square by 2as. V square is 0 when the car is stopped. V square is 72 kilometers per hour. We find that value in meters per second. What's that value is 20 square in the acceleration minus 2 is 5. We want to find s. Then we should take these values in this side. Then s equals 400 and s equals 40 meters. Car stopped in 40 meters. Then obstacles in the distance 35 meters. That means the car is hitting that obstacle. The car will be hit the obstacles. In this question, they say this car has ABS brake system, anti-lock brakes. That means when you apply the brake, then wheels start slipping. When the moment wheel starts slipping, the system controls the brakes and release the brakes. Then it's not slipping and then it starts rotate, and when it starts rotating, in that moment the brakes apply again, then it starts to slipping. That happens in milliseconds, micro milliseconds. The car is not slipping in that moment when ABS is applied. Car is not slipping, and it is in between the slipping and in the situation in slipping and not slipping. We cannot say it is not slipping, and we cannot say it's slipping. That's why then that ABS applied, coefficient friction becomes close to the Thevenin friction. The value they given to take value as the 0.75. Then ask calculate the new stopping distance from the ABS. New stopping distance, we have to calculate the new friction under the ABS braking system. F ABS mu R mu 0.75 R 12,000. Then we should calculate the acceleration. F equals in A 9,000 equals 1200 A 90 over 12 means 45 over 6 equals A. Then we have to calculate V square equals U square minus 2AS V0 U20 square minus 2 A is 45 over 6 into S. Then we take this value to this side. Then 45 over 3 S equals 400. Then 15. Okay. Then 230 and 10 100 50 100 or 50 100 or 50 6.7 equals 26.7 meters. Then the observers at in a distance of 35 meters. In this time, when the ABS system is applied, car should stop in 26.7 meters. At this time, in this time, car does not hit the obstacles. Car does not hit the obstacles. The last question. The cars test the horizontal circle and the road radius. That means a circular path. The radius. The car is going in this circular path. When some object is going in circular path, it should be attached to the center, or some force should apply to the central direction, because the centrifugal force applied in this direction. And centrifugal force applied to the center. This is the friction force. The centimeter force is, in this situation, centripetal force is the friction force applied by the tires. This is moving. Find the maximum. Find the what's the centrifugal force F equals mv square over r. That is centrifugal force equation. F means the friction force. The centrifugal force is the friction force applied by the tires in this question. Then the car, this is the opposite rear view of the car. And car going in this direction, centrifugal force applied by the tires to the direction of the center. That only car can move in the circular path. When this force is brake or this wheels start slipping, the car goes in that direction, not the circular path. That's why the friction force is very important when the car is going circular path like bends. That's why that's more important. Friction force. Friction force is mu r. Mu is limiting friction. Why is that limiting friction? Because car is not slipping. Car is not slipping means this limiting friction. M v square over r. R means the mass. Mu L is given in the B section. Mu L limiting friction coefficient is 0.8 and reactive force is mg 12,000 mg. We can write as mg because m is going in mg is 10, 8 equals v squared of r. R is the radius. Radius is given. Radius is 18 meters. 8 over 18 equals v square. 8 over 18 is v square. 8 64 4 8 plus 6 2 equals v equals 12 and s minus 1. That's the maximum speed the vehicle can take under the circular path. When if the vehicle reach the 12, then vehicle reach the max